Marco Montes from CATEC. I'm working here in the Perception and Artificial Intelligence unit. And I'm going to present the secondment made with the University of Thessaloniki during the 2 months where I will be there. Here is a table of content, but I prefer to go deeper in the problem. Basically, the problem that we are trying to attach or to address is the development of a tool to media content generation. This tool will be based on an artificial intelligence that is able to generate aerial images from a object from a point of view that was known but not previously visited. Okay, so basically to understand more or less the problem, when you are trying to generate novel views, you have two kinds of problems. The problem of the interpolation that is shown in this diagram with the cyan. I don't know if you can see my mouse, but it's shown with the cyan or with the blue axis. That is basically a point between two known poses, or the problem of the extrapolation that is basically the purple one. And if you can understand, this is the difficult problem, and is the problem that we are going to try to address in this tool or during this secondment. Here is shown the architecture of the whole tool or the proposed tool. It has three main modules. The first one is the cinematography area robot. Of course, is the one who has the camera, the one who takes the pictures. The other module is the shot type generator. Basically, this is a module based on one article from the people from Thessaloniki, and there is defined mathematically a wide range of different subtype trajectories. We will go deeper later. And the last part of this tool is the GeoGPT transformer. That basically is the module where the images are generated, and the applicability or the goal of this tool is generate the fixed number of desired novel views from known but unvisited point of view, basically to extrapolate some images. I'm going to go deeper in each part of the proposed tool. The first one is the cinematography area robot and its environment. Basically, we simulate the environment with Unreal Engine, and we decide to create and to test this tool in two different scenarios or two different use cases. The first one is the industrial use case where we have our refinery. This way we can test or show the applicability of this tool to make inspections, to make visual inspection, or to make another kind of inspections in the industrial environments. And the other environment we create is the monumental environment. In this case, is Egypt with a pyramid. And this is to simulate the environment and to simulate the aerial robot, which is formed by the camera and the drone itself. Basically, the telemetry, that is the position, the velocity, and the orientation of the drone. We are using Ersyn, that is a plugin developed by Microsoft to Unreal Engine, and we are using the API of Ersyn. Here can be seen is shown an image from the drone of these two environments. So with this, we are able to create an environment and to create a drone flying inside of it. Later, we decide to from this article, we decide to take a small range of trajectories and important trajectories, use it, and we made some assumptions. So the first one is that we have an statical object whose position is known, and of course the velocity because it's 0. And we decide to take 3 shots. The first one is the orbit one. that is basically a rotation around a fixed point, that is the object, the interest object. The other one is the flyover, that is basically a movement pointing and keeping the object in the middle of the camera. And the last one is the flyby, that is recording, taking the object at a fixed distance from the camera. So we decide to implement these three options in our tool. Later, going deeper in the GeoGPT transformer, basically it's an architecture based on this article, that is the synthesization consistent long-term 3D scenes video from a single images. And the idea is that this architecture takes as input only one image and the camera trajectory that we want, and the output of the model is the new or the novel views, the perceptual consistent novel views to each element of the trajectory. But how it works? Basically, I'm not going to explain the transformer, but the good point is that it working as a autoregressive sense synthesis that takes the current image and the previous one to generate the next one. So in this way, they're trying to ensure the photoconsistency or the long-term consistency of the new images of the novel views generated. And to make this tool usable in some way, we decided to implement it in ROS and Python 3. I don't know if you are familiar with ROS, but in the robotics are so use it. And basically, ROS work with nodes and with topics. The nodes are like entities that make things, and the topics are the way of this entity communicate through messages. So in this tool, we decide to create two nodes. The first one is the one that publish the desired positions, take it from the trajectory generator and the current image of the aerial robot. And the other node is basically the node where the inference was made. It's called lookout infer node, and take as input this image and the poses array and publish the decided novel views. Okay, and to test or to evaluate this tool, we decided to evaluate the spacing, the space between each viewpoint that basically is directly resonated with the speed of the drone of the UAV, and we are trying to find where we begin losing the consistency or the visual consistency of the model. In this way, we are able to test or to evaluate how is or what is the maximum speed of the drone to be able to regenerate all these new points of view. To evaluate this point, we decide or we take two different metrics. The first one is the PSNR, that's basically measure the pixel-wise difference between two pixels. Of course, this if this value is higher will be better. And the other one use a deep feature space that basically measures the similarity between two. And to perform these experiments, we decide to make some assumption and to fix some conditions. The first one is that for now we are going to work only with the orbit subtype, and we are going to work only with the pyramids or the monumental or Egypt environment. And the other assumption that we made is that the aerial cinematography robot, basically the drone, takes one picture per second, so that's why I can talk between in gaps between one gap represent one picture. And this is the results or the evaluation, sorry. Here seen or is present different gaps of different experiments with 10 gaps per different. For example, in the first one, you can see how the how the prediction are more or less exactly the same of the ground truth. So it makes sense because if the drone is flying or so slow and you are generating images with a lot of overlapping between each one, you will create easier the new images. But if we increase the gap in the 25 one, the first images are more or less quite good, but from the third one, we begin losing this consistent and this visual long-term consistent, and the last one we only are able to create the first one. So basically, the result is that if we found a trade-off between velocity and consistency, we are able to generate this new novel view from this unvisited point of views. And as a conclusion of this presentation, basically we'll be able to present an end-to-end tool to generate this media content, this image media content, and we address the difficult problem that is extrapolation of the images. If we think in generate the interpolation of the images between two point of views more or less easy because we know how it's seen from each side, but this from this point of view is more difficult, and we think in different use cases. For example, the first one is a visual based trajectory optimization, that is if you assume that the prediction of the model is the ground truth or is the image that the drone must see, you will be able to create a control error between the image that the drone is seeing in this moment as the ground truth generation. So in this way, we can create some kind of advanced control strategies based on visual images only. Another interest use case is the competition of aerial image footage or visual inspection. Imagine that you want to perform an orbital which around an object to perform or a video or an inspection, and in the middle of the experiment you lose the battery and you need to land the drone. So with this tool you will be able to regenerate the part that you lose from the object that you are recording. So this will be interesting as a future work on the of this tool. I think that will be so nice to change this transformer for a diffusion model that right now is shown that is more or less the state of the art of the image generation, but during this secondment will not be able to make work in a good way the diffusion model. So that's why we decided to work with transformer. And another good improvement or work will be the modification of this transformer to learn the camera, the new image, and the trajectory. In this way, we will be able to give us input only the image of the drone and the name of the token of the desired shot type, and the model will generate the whole image without taking into account the trajectory generation only during the training. So that's all from my side.